Ladies and gentlemen, good day. This is Glenn Tan speaking. This time, we are going to talk about the GMV water cool. And from these pictures, I will focus on this outdoor unit. And this presentation divided into these 5 parts. First is product introduction. First of all, what is GMV water cool series? And from the name you can also find that actually for the refrigerant piping, which is this part, they are completely the same as the air cool series, which means you can individual control for each indoor unit, which means that for the temperature setting they can be different. And for this, it can ensure the comfortable and flexible of the indoor units. On the other hand, and for the different is the condenser side, which means for the air cool, we find that the pressure difference between the high and low pressure is too much, leads to the system operating efficiency is not that high. So we just consider that why not just we apply the water to cool down the condenser. So this can higher the system operating efficiency. And for the water, which is similar to the chiller, which means we can use the cooling tower, of course, and also we can pump the water into the earth, which use the geothermal energy. And on the other hand, we can also use the factory waste heat for the heating. And for this, and here is a summary, you can find it. For the water cool VRF, which is the water system, which is this part, plus the indoor unit VRF. And for the water, just instead of the cooling tower for cooling and boiler for heating, if we can use the water, for example, from the river, from the lake, or the underground water, or the sea water. And for this one, we can also use it to cool down or heating up the water system. And for that, we can higher improve the system efficiency, especially to avoid the influence of the air source on ambient air and reduce the heat island effect. And here is the product lineup of GMV water cool series. Currently, we have from 22.4 kilowatt to 33.5 kilowatt. And also they can be modularized. The upper limit is 4 outdoor units. So the max capacity can be up to 134 kilowatt. And also you can find it from here. Here we listed the water flow rate and the pressure drop on the water side. And also we use the preheat exchanger, and the compressor is the same as the air cool. And finally, it is the power supply, which is the last one, last alphabet. And from here, you can also find that currently we have 2 models, F and X. And here is the comparison between the GMV water and our air cool GMV6. And from the model, you can find that the capacity is the same, 28 kilowatt, and the rated input power for cooling. And for this one, is you can save power a lot. And also the noise, as the outdoor unit, there is no fan, just a compressor, so the noise is not that high. And for the heat exchanger, this is filled in tube. For this one is per heat exchanger, and definitely this one is higher. And there's no fan. And for the size, for the water cool is about 35%, just compared with the air cool. And for the footprint is about 60% of it. And for the net weight is about 3/4, which for this 3, which means it is easier for the water cool to transport. And just like what I said, for the indoor unit, the wiring and also the connection is completely the same as the air cool, which means for the outdoor unit, they just connect with the multi indoor units, and each indoor unit, the setting, they can be different. So from this picture, you can also find that this setting is different, and all this can hire the indoor unit comfortable. And if in some projects, for example, in some hotel, and just like this case, and the outdoor unit just share the water system, but the indoor unit, they are different. So this one, they can be do the heat recovery, which means for this one, they're just doing the heating, and for these two, they're doing the cooling. So we will generate the cold water, and these two generate the chill water, so they can mix together, and here we can make it to bit heat recovery. This can further save the power. And this is the operating range of the GMV water cool series, and here is the water flow rate range, and this is the water temperature range from 10 to 50 degree, and this outdoor unit ambient temperature range, this is for the service room, which means the outdoor unit should place at the service room, and it should be above 5 degree and below 40 degree to ensure the system reliability. And from these two pictures, you can find that for this zone, it is the stable operating zone, and also for this white color, it is a stable operating zone. And for this one, you need to adjust the water flow rate to ensure the system can operate smoothly. Also this zone, and also here. And for this one, which it means if the water in temperature is lower than 10 degree, the system will lock down. But if you put some antifreeze into the water to adjust, which means to lower the freezing point from 0 to, for example, -2, -3, and you can also lower this zone, and the lowest we can make it to be -8 degree, which is this one. And this is the comparison to the air cool series. First is the noise comparison, and as you can find it for the air cool, there must be a fans for that. So for this case, the noise must be higher compared with the water cool. And on the other hand, it is that for the water cool, we don't need a special service floor for it. We just need a special small size service room. An airway floor is okay. And for that case, we can save the space. And also, if you have some special requirement for the building, for example, all the glass without the service floor, for water cool, it is available. And also for this one, it's also easier to install. And for the refrigerant cycle, they are very similar. And we also adopt the subcooler to achieve the deep subcooling. And also, and this is the outdoor unit of the water cool, and here it is the preheat exchanger to exchange with the water, and this is subcooler, also a preheat exchanger, and the function is very similar, which means for cooling, and this one coming out from the heat exchanger, which this is already become the liquid refrigerant, and then a partial refrigerant will get from the main row and get expanded at this EXV. Then it become low pressure and temperature. Then it can absorb heat from the main row itself, will just become the gas and flow back to compressor. So the main row, the liquid will become more cooler, and then it can flow to the indoor units. Do you know what is the purpose of why we need to set up this subcooler? Or what's the benefit we can get from the subcooler? Okay, and the answer is for this one, we can get a higher subcooling degree, and of course, right? And why we need this one is, on one hand, as you can find it, uh, the liquid coming out from this outdoor unit, it is destination, which is the furthest indoor unit to the outdoor unit. For example, this one, and the further this it is, which means the refrigerant, when it flow to this destination here, if the more likely it will become gas, right? And then if it will become more cool, which means we can cool it down, then to ensure when it get to the furthest one, which is this one, it is still remain liquid. And on the other hand, if it get expanded at this EXV, which is here, and if it just contains some gas, it makes the expansion process to be turbulent. And for the customer, they will just find that why my indoor unit is just so noisy, especially when the customer is going to sleep, and always they will turn down the fan speed, right? At that time, the noise, which is this one, will become significant. You can also consider that you're just going to drink a Coca-Cola, and before you drink it, if you shake a lock and then open the cap, and what's the sound you will hear? Sha, right? And if we make it to be completely liquid, we can make this process to be peaceful, and the noise also will become much lower. And this is this two preheat exchanger. First is the condenser, we just called it. It is from Danfoss, and also the subcooler, which is this one, also from the Danfoss. And here is the working process of it. And also you can find it the plate on the left and right side. And this is the sectional view. Is different uh, flow. They just make heat exchange inside. And also you can find it for the prey itself, we just make it to be very turbulent. Also makes the heat exchange to be very turbulent, which can higher the heat transfer efficiency. And also you can find it for this one, as the gaps is very tiny, which means we require the higher water quality. And this is why we require the cooling tower to become close tight. This is the inside structures of the water cool. Just dismantle the panels, and you can find it here inside it. We have the pressure exchanger to the water subcooler, this one, and this is the gas liquid separator, and this is the cut-off valve, gas pipe, liquid pipe, and this is the four-way valve. This one is the accumulator, and this is the oil separator, and this one is of course the compressor. And actually here is a electrical box, and from this one, and there are basically three boards, which is the control board. Here inside is the control logic, and this is the compressor drive board. This is the filter board, and this one is the phase sequence protector. And for the water cool, and when it is doing the heating, just compare with the air cool, you can find it. For the air cool, it needs the defrost if the outdoor temperature is low, and for the water cool, there's no need because we just need to ensure the water temperature is not that low. It's okay. And also we don't care the outside weather, either it is sunshine or rainy or the snow is the same. And also the same, we also have the alternated operation, which means in park load condition, according to the load to turn on or turn off the outdoor unit to maintain the temperature. And for the outdoor units, there are basically 8 hours to change. So for example, in this case, it just require 2 outdoor units to turn on. The other one is just to rest. So it operate first 8 hours, then to the next 8 hours, we go to this 2. And then operate another, we go back to this 2. And also for the outdoor unit emergency operation, it's the same, and which means inside it, if there in the system there are 3 outdoor units, if this one become malfunction, we can also set on this switch on the control board to the emergency operation to allow the system continue to operate, but the time limit is 48 hours. And the same as the air cool, we don't need a BNS for the stop setting of the outdoor unit. You can just connect to the fire alarm light switch or the emergency stop to the outdoor unit, then it can stop immediately. So for example, in this case, in this building, they are just installed a water cool, and then if we find that there is a fire here, and this fire alarm just will send the signal to the outdoor unit, then it can turn off the whole system immediately. And also the same, this system support the indoor unit priority function, which means on the indoor unit, if you set the indoor unit with the priority and the outdoor unit already activate the priority operation, then the system will only allow to operate the indoor unit with a priority. And this is just for example, if the power supply is insufficient, you just use this power generator for the power, and then you just allow your appointed indoor unit to operate. So you can set on this function just like this. That's all for this part of the presentation. If you still have any other question, just feel free to contact me on my personal email address.